Hi, in this session what I'm gonna present to you is basically a couple of steps and procedures that you may consider during the modeling 1D element as a beam embedded into the solid elements. So for that purpose I'm gonna make one mock-up model, say it one simple block. I place one line at the corner. I'm gonna move this line to the center. Okay, so now if I change the view to level of transparency to the middle, so you can see the beam, or say it, our 1D line is in the middle. The next step is to define material property and physical property for two segments that we have. One is solid, another one is beam. So first we start with the solid one. I create one from our database, close, and the other one will be for our beam. So I define something again random from our database, and I change that to beam. I change the name of the first one to solid, just to give you some indication. The next one is physical property. The first one is our 3D, which is solid, and this one is solid. The property, material property is solid. Click OK. And here what we're gonna do is we're gonna define a kind of 1D reinforcement segment. How it works is like that. We go to the selection, reinforcement. In terms of reinforcement section, I call it beam section, and the corresponding 1D element reinforcement with property, with corresponding properties. Here we go. Beam, beam, 3. So the cross-section area here is dummy, so this dialog box is for truss type of element. That means, for instance, circular type or one specific type of cross-section. But later on, we're gonna show you how you can change this cross-section to different type of profile type, U-shape with angle, or I-type of shape, different type. So for time being, I just define one, click OK, close. So the next step is meshing our solid. I'm gonna mesh, map mesh. So make sure that this line is in the middle. So now you can see our beam will be considered as a kind of embedded one. So I mesh my solid, and the next one is I'm gonna select the line just to give you some sort of indication. I'm gonna select the line, number of the division 1, bar in solid, and click OK. So program automatically create a kind of embedded element out of our 1D element. So the next one, or the next step, is assigning boundary condition. I set my boundary condition like this, very simple. In X, Y, Z, apply. Also, I'm gonna assign rotational degrees of freedom to my, or constrain them to my beam. So I select this one, both ends, and only rotational in say it along the Z or over the Z. Show, so we have everything. The next one is imposing force. So I'm gonna go to the pressure, load, 3D face. I select this guy, normal, for instance, minus, something like this. Just mock up to give you some indication how it looks like. So at this moment we are good with our model. What I'm gonna do, I'm gonna save this as a test model. So now I'm gonna transfer all this information and the model into basically a mesh editor, and over there are a couple of steps that we should pay attention to take care of them one by one. So I go to analysis, edit the model with Diana, with mesh editor. So the fact is, when you define embedded element, especially through the bar or beam or truss, there is a default settings with activation of the interface between our 1D element and surrounding element. So therefore, if you want to consider bond slip or say slipping behavior or dilatation behavior, you need to assign set of parameters for those behavior. This could be kind of tau sigma displacement or diagram, between the traction and normal stress, or you may define DSTIF parameters like Kn and Kt, two parameters, one normal direction, another one is shear direction. So here what I'm gonna do, I will go through the things one by one. From here, I'm gonna expand Materie, and for beam, I right click, properties. So here is the part that we're gonna introduce DSTIF. DSTIF is the parameters for stiffness between for the basically interface. So DST program automatically recognize that, and I'm gonna consider our interface linear elastic but kind of rigid. Therefore, for instance, 1E8 and insert another one, 1E8. So this basically is high enough to ensure there is no slipping, there is no separation between the surrounding concrete or surrounding soil and beam in between. So this is our DSTIF. Just I want to highlight here, for instance, thermal expansion is a default value is there. So later during the analysis, if we see one warning that there is no thermal analysis and this Thermax has not been used, don't worry. That's because we already have this parameter. So program says we didn't use this parameter. So this is at the material level. Then at the geometry level, this is important. Why? Because here we're gonna specify, okay, the beam has what type of cross section, what type of dimensions, what is the reference axis, and what is the parameter for the, say, interface around the section or along the beam that goes through. So we're gonna feed this information one by one. But before that, I'm gonna want to draw your attention to this part, predefined shapes. So in Diana, you can specify different type of shapes, even tapered type of polygons or something like that. So for simplicity here, I'm gonna simply select a rectangle, basically with the code of rectan, two parameters, you can see H and B, and we need to specify the corresponding Z-axis, which you can see here, and a parameter that basically specifies or gonna use for interface behavior. So let's start one by one. So this is in 4.4.1 predefined shapes. Here it's explained everything in detail. So here I'm gonna call the first, for instance, for simplicity, I call it rectan. Program automatically recognize that. The dimensions. So I define 1 and 1 for simplicity. The next one is z-axis. So I define -1, 0, 0. This is the reference for basically projection of the results. And the next one is our the perimeter, but forget about here it says pi parameter, but this is not the case. In this case, we are dealing with the surrounding part of the our beam cross section. So the perimeter here is basically 4, and we are good at this level. The next one is element data. So in element data, we have one important factor, and that is we say this interface can be considered as a truss, that will be like tendon, that will be like basically reinforcement, or beam. The beam can be used either for embedded beam, that the purpose that we are using, or for pile type of elements. So here what I'm gonna use in F is the bond slip interface behavior, and here I indicate the type is beam. So up to now we are okay. Click OK. Now you can save your data file. Save as. I can call it test. Save. And you can run the analysis. Linear static just for illustration purposes. So this is the part that I was saying. There is a kind of warning. There is just general information that the Termex is signed, reinforced, but basically because we do not use any, thermal analysis or transient analysis, therefore the variation of the temperature in the embedded part is kind of ignored. That's not a big deal. Click OK. OK. Then you can go back to your model, import the results. Make sure that when you are importing the results, you import both basically your DPB and the corresponding DMB, because the results of embedded are in this part. Import. You can see the general deformation. And here under the 1D, you can see all the fiber reinforcement, say in the fiber position at the corners. In the middle plane, stresses, strains, axial forces, if I hide my box. And if you have some eccentricity and others, you may get your bendings as well. And corresponding relative tractions and displacements. These are the relative displacement, and these are the relative, or the tractions. There is one more important thing here is I would like to highlight, and that is in the dat file that we stored. If you scroll down, here you can see all those reflections. So if you want to change your DSTIF, you can easily change them and reload your dat file. This is very important. You have to close your previous one and reload the new one. If you want to change the section, for instance, here it's a rectangle, but for instance, you want to use I. So in that case, you put I shape and the corresponding parameters in a sequence. So here you can see the sequence and the order of the parameters. You can input them, calculate the parameter, and set it up here. And don't forget about interf beam. So hope this tutorial give you some sort of indication about modeling embedded beam in the solid.